Construct an angle of 90 degree at the initial point of a given ray and justify your construction. So we are looking at drawing 90 degree at a point basically. So a ray is what? So we need to talk about ray first. Ray is nothing but kind of a line wherein you have a starting point but there is no ending point. So at the starting point we need to draw 90 degree. So for this we need to draw an arc with A as the center. So arc is nothing but part of a circle which need not be complete entire circumference. I can just stop anywhere, something like this. That's good enough. And let's call this as point D with the same radius. What radius? Well, from point A as the center, if we happen to draw some radius, say of 3 centimeter, so this arc radius is 3 centimeter, right? So with the same radius from point D, cut one more arc, so that's E. From E, cut one more arc, that's F. So all these lengths are same. With F and E as the new centers, take an arc length which is more than half the length of FE, or don't think too much, take the same arc length, okay, same protractor length, and continue to cut two arcs from F and E as a center. Just go with that, don't think too much, that's good enough. So this is your perpendicular line and we can call this as point P, and PAB is 90 degree. So take out your compass, protractor, scale and everything. Let's do it on a sheet of paper. So let's actually do this practically on a sheet of paper. So we have a ray which I have already drawn. So with the starting point I need to draw an arc of any length. You can see clearly that I'm taking some random length. I don't know what is the radius of that. I'm drawing up to 120 degrees. That's enough. So now I'm not changing the radius. That is very important. I need to continue to work with the same length as what I started with and cut two arcs, as you can see. With this as the new centers, with this as your new two centers, cut two arcs. The condition is that it has to be more than half of the distance between those 2 points. So don't worry, don't think too much, just cut two arcs. Any radius, any length, they should cut. So mark the point of intersection and you have your perpendicular line. So you can see that it's 90 degree. Okay. Right. So that's your 90 degree. And let's look into steps of construction. So let's reconfirm what we just did. So this is your ray A, B. Taking A as a center and some radius, draw an arc of a circle. So this is your arc 1. I'm calling it as arc 1 for the sake of discussion, which intersects AB at D. So this is your AB. This particular arc is intersecting at D. Taking D as a center and with the same radius. This is very important. Here it's some, here it's same. Draw an arc intersecting arc 1 at point E. So that's your E. Draw another arc with E as its center with same radius intersecting arc 1 at F. So that's F. So all these lengths are of same length. Please keep this in mind, okay? With E and F as a center, draw an arc with radius more than half the length of EF. If you ask me, just continue with the same length. If you guys want to, if you have constraint of something, the condition is this: it should be half the length of EF. See, this is EF, right? Between these 2 points, from these 2 points I'm trying to cut an arc, kind of, right? We can see I'm cutting 2 arcs over here. So with this in mind, see to that you take at least half. To be frank, it should be more than half. If you do at least half, I think that will be an issue. Okay, it should be more than half. If it's less than half, they won't cross each other. That's the whole point. Okay. So with more than half, we should cut, and you have this as point P. Okay. Don't think too much. I'm trying to emphasize on the 4th point. Don't think too much. You guys will get it. If you do take less than half, then these two won't cross. So that's not an issue. You can erase and take more than half and draw it. So nothing wrong will happen. The diagram won't be that clean, that's all. Then EAP will be your 90 degree. So now the question is, how is this 90 degree? Let's justify this. Justify means let's prove this with values, congruency, that, this, and all of that. So justification. So for justification, we need this diagram, and we need to join quite a few things. So I'll start off first with joining ADE as a triangle. So what does ADE look like? Any idea? Consider triangle ADE. Here AD is equal to DE is equal to EA. The reason is all of them are radius. So with this in mind, what can I tell you about triangle AEB? ADE. So therefore ADE is an equilateral triangle. Okay. So this fact is useful. So this implies angle EAD is equal to 60 degree. So this angle is 60 degree. Good. So if I prove that this is 30 degree, we are done. That's it. So let's do that. Now consider triangle. Can you guess which triangle is next? Yes, AEF. Right? So we have AEF. So triangle AEF. So here too, AE is equal to EF is equal to AF. All these are radius length again, and thus making, therefore triangle AEF is an equilateral triangle. So what does the angle become? The angle FAE will become 60 degree. Okay. Now what is next? We have to consider triangle AFP and APF. So we have A, PF and triangle APE. So these two triangles are congruent. Why? AP is common. Then we have AE is equal to AF, which we already written that they are equal because they are radius, and FP is equal to PE. Right? Construction is done in that way that they are of same length. So that is because of construction. So what does this make these two triangles to be? Therefore by SSS congruency, we have triangle APF is congruent to triangle APE. So with this we can conclude that this color angle FAP, this angle is equal to the neighboring angle PAE. Why? CPCT. If these two are equal from this fact, okay, so this is 1. So let's consider 1. So from 1 we have angle FAE which is equal to 60 degree, and from 2 we have that these two angles are equal. So well, this can be distributed or cut into two parts. FAE can be cut into FAP plus PAE, which is equal to 60. This is from figure. So from 2, what can we tell? So from 2 we can tell that these two angles are of one and the same. So 2 times of PAE is equal to 60. This is from equation 2, right? I hope you guys understood. It's quite simple. These two triangles are FAP and PAE are congruent. Okay, so since those two are congruent, what can I tell? Those two angles are equal. Since these two triangles are congruent, these two angles are equal, and since they add up to 60 degree, each of them have to be, each angle PAE will be equal to 30 degree. So this we can call it as 3, and this we can call it as 4, or A and B, or whatever you guys want. So if I add this to, what will we get? So adding equation 3 plus 4, we'll get angle EAD plus PAE will be equal to 30 plus 60, that is 90 degree. So this is your justification. You are able to justify that this entire angle is equal to 90 degree. Now this is your question. This is your steps of construction. And justification. Please enroll to our program at chalkpieceacademy.com, wherein we'll be teaching you a lot more tricks for faster simplification and calculation, DIY projects. We'll code with Python. We'll work with Arduino Uno. There are a lot more magic tricks and the physics behind it. They are printable materials which will help you recap and understand things better. We'll have live revision and doubt session 2 months before your term exams. It's very cost effective. There would be no ads or any kind of distractions, and we have a dedicated app to help you guys with this.